Okay, so we are now continuing section 5.8, and here's another example that we are going to look at. So let me give you a moment. This is integration using tables. So the previous sections in chapter 5, you used integration techniques, and but now when you reach section 5.8, you're going to use tables to help you. All right, so let me give you a moment to copy this example down, then we'll discuss it. Okay, so with these problems in section 5.8, oftentimes you have to make a substitution. Okay, so if this problem, if you were to make a substitution, what do you think the substitution would have to be? What do you think the substitution would have to be? Yeah, good. E to the 15x power. Very good. Hold on here. Very good, John, Jonathan, and Jasmine. That's right. Now, okay, so we're going to make that substitution, but before we do that, I mean, we got that in our mind, but let's go ahead and look at the table of integrals to try to locate a formula that might work here to help us find this integral. As you know, let me just, let me see here, let me go into the application. So the in section 5.8 in the textbook, there are links that will get you to the table of integrals. And in the course content folder on Blackboard, if you click on chapter 5 integrals, click on the here link. Section 5.8 is there, and there's also a link right there there's the link for table of integrals. Okay, so which you can download that table. So all right. Well, Mandy, for the second part of the exam, you will be allowed to access the table of integrals for section 5.8 problems, but not for part 1 of the exam. Okay, because part 1 of the exam is on sections 5.5 and 5.6. Part 2 is for 5.7 and 5.8. Good question, good question. Okay, so let's see here now. Let's see, look through the table and let's see what might be what might be the right formula to use. Look through the 100. So you know that table there. And you click on the link, table of integrals, to get the table. Let me see here, one moment. Let me just get it here as well.
Professor?
Yes, Clea.
Just so I'm correct, like section 5.9 that we're doing later today is not on the exam, right?
That is correct. 5.9
Okay.
will not be on the exam.
Okay, thank you.
That's correct. Okay, very good. So, all right, here's that table. Here's that table. And, you know, go ahead and look through the formulas there. Now, Jonathan thinks maybe formula, I believe 93 or 95. Let's see if we have some other ones here. Susanna thinks 95, formula 95. Okay, so you have basically, John thinks 95. So if I go to uh, that section here, load that up a little bit, and you can always, so this our integral has an arctangent in it. Okay, and so arctangent formulas. Okay, there's one there. There's one there. So let's see which one. And actually, 92. Like the formula 95 has basically it's a n has a like u to the nth power. But if it were u to the first power, then you'd have formula 92. So we're in the right ballpark here. We're in the right ballpark. And let me see here. We get that problem back. And just a reminder here that hold on, there's my stylus. So arctan is that's notation for this too. Okay. All right. So let's make the substitution u equals e to the 15x power. Okay. All right. And we do that here. And I wrote formula 92 down here for you. Okay, so let me give you a moment to copy here.
Hi, Dr. Judy.
Yes, Susanna.
I'm sorry, I think you mentioned it, but why did you choose 92 instead of 95 instead of the u
Well,
squared?
95 actually, if n equals 1, formula 95 collapses into formula 92. So it turns out that formula 95 is a very general formula. But when n equals 1, it will collapse into this formula 92. And so basically what I would say is, I'll show you why n can't equal 2. Okay, I'll show you that. One moment here. So let's say I'm going to let u equal e to the 15x. Okay, then so now I have here the arctangent of u. So what's left then is, okay, this 15e to the 30x and this dx. We have to get those in terms of, if we can get those in terms of u, okay, let's do that first. So, okay, well, since u equals e to the 15x power, that means then that du is 15 times e to the 15x dx. Now let's take a look at our integral here. Here's our integral. All right, and the e to the 30x power, okay, this e to the 30x power, I can write that as e to the 15x times e to the 15x. And it just so happens then that by doing that, and then just reordering the terms in the integral, I will get the an integral of u times the arctangent of u du. And so formula 92 works. Okay, so the trick is that e to the 30x power, I had to break it up as e to the 15x times e to the 15x. And that is true, right? Because e to the 15x times e to the 15x equals e to the 15x plus 15x, which is e to the 30x power. So that's fine. Okay, so formula 92 was good. But remember, formula 92 is, so see, there's no u squared there, right? There's just a u to the first power. You know, formula 92 is good. And so now formula 92, we apply it. Okay, the formula 92 gives the antiderivative of u times the arctangent of, I should have arctangent of u here, du, right? There's the antiderivative right here. And of course, since our original integral was with respect to x, I have to substitute in for u the e to the 15x power.
Professor?
Yes, Clay.
I'm kind of confused about like, so if u is equal to e to the power 15x, and in the 92 formula it's u 10 minus 1 u dx, then what about the 15e 30 power x?
Well, so this part here, let me see here, hold on, I kind of like to keep things highlighted. So you see here what I'm circling in green on the, right here on the screen?
Yeah.
That should help convince you that this is right. Does that? So you notice e to the 30x is equal very conveniently of e to the 15x times e to the 15x. That's no accident. The problem's designed to work out that way. Do you see how, as you work through the steps here, how we end up getting then we transform with the substitution u equals e to the 15x power, we transform the integral into u times the arctangent of u du. Is that okay? Like what?
So you divided the e to 30x into 2 e's of 15x. So you.
Well, e to the 30x, I can write as e to the 15x times e to the 15x. I can do that.
Yeah.
Because you know, you add the exponents and that gets you 30x.
Yep.
And by breaking up e to the 30x into e to the 15x and e to the 15x, then, you know, rearranging the terms here, I get my integral. I mean, I get my integral with respect to u. So it's a little tricky, right? But with practice, you see, and you're having an assignment due Thursday, right, on section 5.8. With some practice, you'll get better at it.
It's okay. Thank you. It's due Friday, right?
I'm sorry?
It's due Friday, right? The section 5.8.
Oh, I'm sorry, Friday. Right. This is a Monday, Wednesday. Right, you're right. Friday. Sorry.
Okay.
Thank you.
Yeah, I mean, I'm still kind of, I don't know, I'm still a bit struggling, but I will try get more practice.
Okay. Well, we'll look at another couple here. If we all right. So now, are there any questions before I go to the next page? Okay. Well then, so Now you'll notice, by the way, I'll mention, when you apply the formula, you put the formula number above the equal sign. That's standard for showing your work. Right. All right, well now I can like, this, well, so of course this answer here, I could type that in WebAssign and WebAssign would accept it. But of course, the quantity e to the 15x squared, I can write as e to the 30x power, right? I could certainly do that. And then, the answer could be written this way here. And so now we have our answer. Absolutely amazing, getting that antiderivative. So somebody, in a number of years ago, worked very hard to get formula 92. And then when he or she got formula 92, they wanted to share that with the rest of the math community. And so thank you, whoever that was. Okay. Well, let's look at a new problem. Let's look at this one. So go ahead and copy the problem down. And yes. Hold on here. So now, all right, Mandy, you're good? Okay. Let's look at this new problem. Okay. So I'd like you to look through your tables, table of integrals, and try to find a formula that you think might work, that might help us with this problem. Susanna?
Yes. Is it generally a good strategy to do a U substitution before you start looking at the table because it can change the way the equation looks?
You're right. You're right. And well, you are right. It's really, students do it differently. Sometimes students like to look through the tables and try to find the formula that might work, and then that might even guide them as to what a substitution would be.
Okay.
What do you think a good substitution here might be?
3x.
Well,
or ln of 3.
Okay. Maybe ln of 3x. All right. But yeah, so let's see here. I'm curious what, looking at the tables, what formula you think might be a good fit. Not a perfect fit, but Okay, so let's see. Xavier is saying formula 41. Okay, Clea says 33. So 41, 33. Oh, 32. Okay. Now 32, there is an issue with 32 because what do they have? What do they have here in this spot for formula 32? They have a square root of a, they have an a squared and a u squared, which is good. But in formula 32, what's there? They have a minus, so that's going to mess that up. Good try, good try. Formula 41, same problem. You gotta have a plus here. You gotta have a plus. Let me see here. Hold on here. Now I gotta get my hold on here. So there's a variety of answers. 58. Well, 58. So here the problem with 58. Maybe I'll just write the for 58. Okay, and Mandy says 23, and Xavier says 23. For formula 58, on the left-hand side, you have the integral of the square root of a plus bu, all over u, du. But there is an issue here because what you have here is a function of a variable squared. And here in formula 58, the u is not squared. So that's going to be a problem. That won't work. Good try. Good try. I tell you what, formula 23 is the closest, but but it isn't quite right. Let's go look at the solution and let's make a substitution. But you're warm. If you're at formula 23, you're very close. So I just wanted to show you, I'm trying to help guide you a little bit, So all right, here's the integral, and we're going to let u equal the log of 3x. Okay, if we let u equal the log of 3x, then du dx is 1 over 3x times 3 by the chain rule, right? So the log of 3x, the outer function is the log, natural log, and so the derivative is 1 over 3x, and then the inner function is 3x. So this is your chain rule times 3. And so that means then that du dx is 1 over x. Okay, and and I guess I have the detail there. And so du is 1 over x dx. So with this substitution, the square root of 16 plus the log of 3x squared becomes 16 plus u squared. We're happy about that. And then the 1 over x dx, that becomes du. And so now we have our new integral. And that's right, yeah. Therefore, formula 21. Okay, so How many kind of like looking at the formulas first before the substitution? Does anybody kind of looking at the formulas a little bit? Okay, Xavier does. And hold on here, another person. Who was that other person? Mark does. Okay. All right. How many like maybe making a substitution first? All right. Jasmine does. And Niet says she finds it easier to substitute first. So, okay, people are different. And that may be true. That may be sort of true. I think that may be, everybody's different. But there may be some truth to that. All right, well, look, so the 16 is 4 squared, right? 4 squared. And so now we have this integral. And now I apply formula 21. And so I have my antiderivative, but our original integral was with respect to the variable x. So now I have to take the u and substitute in the log of 3x. I got to put that back in everywhere I see the variable u, and that's what I did here.
Professor, so should we do the substitution first before we find the formula, or should we find the formula first? Because like sometimes we do this, sometimes we do that, so like it kind of
Yeah,
confuses.
I think it's going to vary. The thing is, there occasionally you'll see a problem where you don't need a substitution. So I don't want you to be saying, yes, I must find a good substitution first. You might be able to use the tables directly without a substitution. So I kind of like flexibility. Generally, I like to locate sort of the section of formulas that would apply to my integral, and give myself an idea of, hey, I think this one probably is the right one, and then I do my substitution. You see, because you never know, the formula, the integral formula from the table might work without a substitution. It's kind of rare, I'll tell you, but it happens.
Yeah, I get it, but like, how do I know like if I need to do substitution or not? Because like I may get the wrong
Well,
formula.
if you're like if you're in the area, if you have identified a formula that you think is pretty close to your integral, then when you make the substitution, if the integral collapses basically into a form where you can use your formula, then you're good. You see, so yeah, it's just sort of well, that's what practice does. That's what your homework's going to do. The one. Well, you're going to have 2 assignments, one due Friday and one due on Monday. So between those 2, I think you're going to get more comfortable with this. So very good question. Very good question. This is section 5.8. This is on your exam. This will be on part 2 of your exam, what you're learning here. So Mandy, I used formula 21 because look, it's a match. Look at formula 21 in your tables, and formula 21. Let me see here. It is one moment. So formula. Let me see here. Let me just clear this up. All right. So formula 21. No, I took care of the x. I took care of it. The dx over x becomes du. I took care of that 1 over x. I took care of that x there in the denominator. By virtue of the fact that du is 1 times x dx. Now formula 21 starts off on the left with the integral of the square root of a squared plus u squared du. So that's a match. That's a match for our integral. You see that? Okay, you're welcome. This is section 5.8. That's right, Jonathan. So they're really like little puzzles. That's how I look at these section 5.8 problems. In a sense, they're like little puzzles. I think we should look at one more. I think we should look at one more here. So let me know when you're ready here, and we'll go to the next example. No, Xavier, formula 23 would, formula 23, here's the problem. Let me see here. Here's the problem with formula 23. I'll write it down here. Here's formula 23. So formula 23, the integrand is the square root of a squared plus u squared over u du. And, you know, if we let x be u, then, you know, that x would be equal to u, dx would equal du. But the problem comes here. Yeah, formula 23 would have to have, that's, well, there's a little more to it than that. But yes, it's the log of the 3x, it's the log of 3x under the square root sign that's causing formula 23 to not work. That's right. That's right. Okay, well, let's look at another one here. Okay, well, let's look at this one. And of course that, now the 5, I'm going to pull that out front. So a substitution would definitely be, I agree, substitution here, Jasmine, would definitely be u equals the square root of x. So let's see if we can find a couple of candidates. A couple of candidates. So Xavier and Mohammed are saying maybe 88. Why don't we pick 2 candidates? Maybe 88, formula 88. Maybe formula 91. Okay. Well, we're going to make, okay, that's right, Mohammed. That's right, Susanna. So we have 2 candidates. you know, that are, one of them's going to work. I'll tell you that. It's one of them's going to work. So let's see here. Let me see one thing here. So let me just do one thing here. All right, I think we can go right to where we make the substitution. Let's go right there. All right, so here's our solution. This is fine. So we let u equal x to the half power. Then du dx is 1/2 times x to the negative half power. I'll multiply both sides of this equation by dx. Okay, and then simplification occurs here. This means that du is 1/2 times x to the negative half power times dx. And if we look at our integrand up here, we have the arc cosine of x to the half power. So of course x to the half power is the square root of x, okay? All right, and question is, what's dx? What's dx? Well, all right, so I have a dx here that I need to get alone. So that means I want to simplify out. I want to simplify out the 1/2 times x to the negative half. Well, all right, if I multiply 2 through the equation, 2 times 1/2 will be 1. Okay, and then if I multiply x to the half power through the equation, well, x to the half times x to the negative half, x to the half times x to the negative half equals x to the half plus negative half. That's x to the 0 power, that equals 1. So all of this here equals 1, and so dx is 2u du. So now we know what dx is. It's 2u du. The 2, we had to get the 2. The reason I needed to multiply this equation here through by, well, let me be more clear. So what I'm doing is this equation here, I'm multiplying both sides of that equation. I got to draw a little more carefully, by 2 times x to the half power. Let me be more clear here. So this equation here, I'm multiplying both sides of that equation by 2 times x to the half power. So I'm choosing that. Now, why am I choosing that? Well, I want to get the dx alone, which means that in front of the dx, I need a 1. So 2 times 1/2 is 1, and x to the half times x to the negative half is also equal to 1. You see, so that's why I chose 2 times x to the half power. It's so I could get a 1 in front of the dx. And so dx is 2u du. And now this integral here becomes 5 times the integral of the arc cosine of u times 2u du. Are we good, Mohammed? Does that make good sense?
Professor?
Okay, okay. All right, very, yes, Claire.
So what I don't understand is like the formula 91 is for u cosine of u du, but we don't have a u before cosine, or is this a formula like the closest we can get?
Well, formula, so of course, you know, this 2 here, I'll bring that out front, and so that gets me the 10. So I have 10 times the integral of u times the arc cosine of u, and that's a match with formula 91, isn't it?
Oh, so we get out the 2 and we put the u in front of cosine.
Sure,
Oh, okay,
sure.
I
I
see.
mean, yeah, everything's being multiplied here. The cosine of u times u is the same as u times, I'm sorry, the arc cosine of u times u is the same as u times the arc cosine of u. So, yeah. Good question, good question. And now we can apply formula 91 directly. And that gets us, now we have our antiderivative. And of course, the original integral was with respect to x. So everywhere I see a u, I have to substitute in the square root of x. Formula 88 would have worked. Javier, formula 88 would not quite work because we ended up, after the substitution, we ended up having a u here in front of the arc cosine of u. So formula 88 was close, but it wouldn't, it isn't, it turns out after the substitution, it's not the right formula. It's not the formula that will work. But you were in the ballpark. See, for me, I guess psychologically, I feel kind of better if I look through the formulas in the table and get in the ballpark, you know, and then, you know, do the substitution. But Xavier, are you good with that? Okay, good, good. All right, well, here's my integral. Now, of course, the square root of x squared, I can just, you put an x there, right? So square root of x squared is just x. And I can write this formula a little more simply, which I'll show on the next page. But I want to make sure we're all good up to now.
So, Professor, if you write it just like this, as you read it in the end, WebAssign would count it as wrong?
No, WebAssign would take that answer.
Oh, okay.
But I don't want to type in all that if I can help it. I want to, like, square root of x squared, I can write that as x. I mean, I'd at least want to do that, just to, because remember, when you type in an answer in WebAssign, if there's a notational error, it counts it as wrong. And so you have to be very careful about that. You know, on the exam, if you have a notational error, it'll count it as wrong. And I don't want that to happen to you on the exam, right? So it's probably worthwhile to simplify a little bit. Very good question, very good question. All right, so let's see if we can, let's see here. So Xavier, sorry, Javier, There will be, for free response questions where you type in the answer, you'll have certainly four chances for each of those kind of questions to get a right answer on the exam. I want to give you, you know the saying, 3 strikes, you're out? How many have heard that saying in baseball? 3 strikes, you're out. All right, Clay. Well, here, you're never out in my class, but I'm going to give you 4 tries, Okay, you're welcome. You're welcome. So this here can be written as 10x minus 1 over 4. All right? Or sorry, 2x minus 1 over 4. All right, and so here we are. There's the 2x minus 1 over 4 here. And, square root of x times 1 minus x, that can just be written as the square root of x times 1 minus x. Okay, then I only need to worry about 1 square root. And I want to distribute the 10 to both of these terms. I mean, why not, right? Nothing wrong with that. And that's going to get me here. But the 10/4 reduces to 5/2, right? And so this answer here is about the best you're going to do. But definitely much easier to type in that answer than the previous answer. So now we have our answer. Are there any questions? You can see how these tables really help you do some tough problems. They really do. Well, the substitution with the tables. All right, let me stop the recording.